7th grade is so into that, right? You guys were, yeah, last year.
It kind of died.
It died, right?
Why
It died after a while.
It died for us.
Yeah. But it's so funny to see that. Okay, so we're going to continue our graphing, all right? Practicing graphing quadratic equations. And up to this point, I've always given you b is 0, right? Right? So immediately, I gave you, like if I gave you y is equal to x squared minus 4, well, you knew immediately that, you know it's standard parabola guy, right? Y equals x squared, over 1, up 1, over 2, up 4. But where? Well, b, if b is 0, which it is here, there's no b. There's no bx. So therefore, for b is 0, we know it's on the y-axis, right? Everybody's clear on that, right? We know the vertex is on the y-axis. The vertex where it turns around, right? And we know it's at the y-axis at -4 because that c is always where it crosses the y-axis, right? So we know the vertex is right there. And then once we found the vertex, we can do the standard parabola guy. Over 1, up 1. Go back to here again, over 2, up 4. And then mirror it. Or you can go over 1 the other way, up 1. Over 1 the other, over 2 the other way, up 4. Right, that's really clear. Everybody's fine on that, right? This to 5, just so I know. Everybody's totally clear on that. Okay. But if you have b, what does b do? It moves it left or right? It moves it off. It moves the vertex off of the y-axis, right? And so now the question is how? It's not obvious. And so this is how you figure it out, okay? So this is the formula that tells you what x is of your vertex. You know how a vertex, when you have a vertex, it is actually a point on a graph. So it'll be x, comma, y. You agree with me? It's going to be a point on the graph. And so this formula is going to tell you what the x is of your vertex. Okay? Does that make sense? And once you know the x, then it's really easy to find the y. Okay? And so we're gonna try this. Let me give you an example. Y is equal to x squared. Let's see. Why don't we say minus 2x plus 4. Okay? Y is equal to x squared minus 2x plus 4. So I am trying to find my vertex. Notice, first of all, look at this. Let me grab a colored pen for a second. This is standard parabola guy. Do you agree with me? Y is equal to x squared. That's standard parabola guy. This stuff just moves the vertex left and right and up and down, right? So if we can figure out how this stuff moves the vertex left and right and up and down and find the actual vertex, then let's say it was right there, then it's standard parabola guy from right there, just like you were doing before. You found your vertex on the y-axis, and then it was standard parabola guy, over 1, up 1, over 2, up 4. If you found the vertex was right there, you put your dot, and then from there you go over 1, up 1, over 2, up 4. Get it? Make sense? So that's what we're going to try to do. So with this equation, we're going to use what's called the Axis of Symmetry Formula. And think about what an axis of symmetry is. When b is 0, the y-axis is your axis of symmetry. And that's what they call an axis where your parabola is symmetrical, right? If I brought this side of the parabola over here, it would line up perfectly with the parabola over here, right? It's symmetrical. So if, let's say, let's say that had been where the vertex was going to be, you'd have an axis of symmetry right there, a dashed line. You know somewhere the vertex has to be on that axis of symmetry. So that's what we're trying to find, is where on the x-axis do I go over to create this vertical dashed line that tells me the vertex is somewhere on that line. Does that make sense? So that's what we're going to do. This tells you. So here we go. Let's try it. So I'm going to use this formula, x equals, and I would recommend, as you do your homework, that you actually write the formula before you actually do the problem, because you have to memorize this formula. It's really, really crucial. When I was a kid, I was not taught this formula. And when I took algebra, they didn't teach me this. And so I used T-charts. And T-charts sometimes, oh my God, it was a nightmare. I'd sometimes have to have 20 X's before I could find where the graph turned around. It was awful. This is your shortcut. This is a huge time saver. It tells you where the graph turns around immediately. So here we go. We got x is equal to negative b over 2a. See, that doesn't take much time to write. But write that first before you write, then you put an equal sign after that. What is my b? It's the number in front of the x, right? See, b is the number in front of the x. And it's a negative 2. Do you agree with me? So what is negative negative 2? This says negative b. Negative negative 2 is positive 2, right? So 2 over, and then it says 2 times a. What is my a? The number in front of the x squared.
1.
That's a 1, a hidden 1. So 2 times 1 is 2. Oh, so then my x is 1. 2 over 2 is 1. See how easy that was? Immediately, look, I know my vertex is 1 comma something. Do you see that? See how easy that was? So easy. So now how do I find the y? Anybody have an idea? Here's my equation, right? This is the equation I'm trying to graph. I now know what the x is. How would I find y?
Wait.
I know what my x is, right? It's 1.
And here's the equation I'm trying to graph.
So I'm saying you have to do 1 times 2 is 2, so that means y equals 2.
So yeah, I'm going to just plug that 1 into this equation, right? Because that says y equals. I want to know what y equals when x is 1. So let's plug it in. So here we go. Y is equal to, and I recommend you write it all out. Don't do anything in your head. Do 1 squared minus 2 times 1 plus 4. You guys see how I did that? 1 squared now is 1. 2 times 1 is 2. So minus 2 plus 4. 1 minus 2 is what? Negative 1, right?
Mm-hmm.
Negative 1 and 4 is 3, right?
Mm-hmm.
4 minus 1 is 3. Or yeah. So 3. So y is equal to 3. Oh, cool. So I now know my vertex. I just put my y up here. The 3 is, since y is 3, so Caleb, you should be writing this down because you're never going to know how to do this if you don't have the same notes. 3, right? So if that's, so now I know my vertex. So I go over to my graph, and actually I probably should have done one thing first, just to show you. When you get x equals, where did we do this? We got x equals 1, right? You see that? This is what I could have done. I could have gone over here at 1, and I could have put a dashed line. That is called my axis of symmetry. And that dashed line is helpful when you're graphing. So it's worth putting that dashed line in. You guys see how I found that? I used this formula. That's my axis of symmetry formula. And I got x equals 1. So I come over here on the graph, and I put when x is 1, I put this dashed vertical line. I know the vertex is on this line, and I know that the graph is symmetrical with that line. Does that make sense?
Yeah.
So now I'm going to graph it. It says 1, 3. So 1, 3. So here's my 1, 2, 3. So 1, 3 is right there. Right? Sorry, Harrison, can you see okay?
No.
Okay, 1, 3. Now from there is it's standard parabola, right?
Mm-hmm.
So I just go over 1 and up 1, dot. Over 2 and up 4, dot. Right? And then notice this is my axis of symmetry. I can just flip it over. This is 1 away from the axis of symmetry here, so I'll put a dot here. This is 2 away, so I'll put a dot here. You with me?
And then you just go.
And now I can just draw it. But that is the key. Knowing that formula. X equals negative b over 2a. X equals negative b over 2a. Say it, say it, say it. X equals negative b over 2a. Okay.
I have a question.
Yes.
Does it at all times have to be a point on the y-axis or the x-axis?
Yes, that point though is the C. Okay? Notice the C is hitting at 4. See what I mean? It's hitting there. But that is not necessarily the vertex. That is the vertex only when there's no B. You with me? Up to this point, before today's class, you knew how to do it without when B was 0. Y is equal to x squared plus 4. So you'd go to 4 on the y-axis, and that was your vertex. Now, though, when there's a B, that number is still a point on the y-axis, but it is not the vertex anymore, because this pulled the vertex off of the y-axis. Does that make sense? All right, so let's try a couple so that we're really clear. And let's try a different one. All right, so let's say, let me just get a new graph here set up. Get rid of that too. Jeez. All right, here we go. So this is my y-axis, this is my x-axis, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 3, 4, 5, 6, 2, 3, 4, 5, 6. All right, so now we're going to do it just exactly like I want to see you do it on the homework, okay, just so you can see. Y is equal to x squared. Why don't we say plus 4x, let's see here, that's going to be 2, so -8, -4, plus 3. Okay, let's say that. So there's our equation. All right, so immediately I see it's y equals x squared. That's standard parabola guy, right? Standard parabola guy. This stuff, I see I have a b. I know it's not going to be on the y-axis. I'm going to use my axis of symmetry formula to find my vertex, to find my x of my vertex, right? So here we go. X equals, I always write negative b over 2a first, and then I put equals negative b. What would it be? Are you writing this down?
Yeah.
Okay. Negative b, what's b? What's negative b? You guys awake?
It's -4.
Thank you. All right, -4 over 2 times what?
A.
What is a?
1.
1. So 2 times 1 is 2. What is -4 divided by 2?
-2.
-2. All right, so I hope this is all in your notes, because this is where, when the x is negative, this is where people mess up. All right, so now what do I have to do?
You have to find out what y is
How do I do that?
by plugging in.
Just plugging it into the original equation, right? So here we go. Y is equal to, now, the only thing is, you see how it's negative? -2, x is -2, right? I'm going to put -2 in parentheses. The parentheses are crucial. Don't do any of this in your head. Just put -2 in parentheses. You put a squared afterwards. Plus 4 parentheses -2. 4 parentheses -2. Plus 3. Now, -2 squared is -2 times -2, which is positive 4, right? So y is equal to positive 4. 4 times -2 is -8, minus 8. This is very often you'll see this, where this number is double this number, and this is negative, right? And this, so it becomes -4. Anyways, I'll show you. So 4 minus 8 is -4, right? Plus 3. -4 plus 3 is -1, right? So y is equal to -1. So immediately I put this -1 here. All right? Now, I'm going to graph my axis of symmetry. Axis of symmetry says x is equal to -2. So here we go. -2 is right here. So I have a vertical dashed line at negative 2. I know somewhere on that dashed line is my vertex. Okay? And then I look at my vertex that I wrote down, negative 2, negative 1. Oh, negative 2, negative 1, and I put a dot. That's my vertex. Now what do I do? Now that I have my vertex on my graph, what do I do?
You go up 1 over 1.
Yeah, because it's standard parabola guy. Y is equal to x squared. So I go over 1, up 1, dot. Over 2, up 1, 2, 3, 4, dot. Notice where that dot is. What is that at? Y is 1, 2, 3. Right? Look at this. That's always a point on your y-axis. That 3. Does that make sense? Right? And so now I'm going to reflect it on the other side. I could just go over to the left 1 and up 1, right? Or I could just reflect it. This is 1 away, I go 1 away. This is 2 away, I go 2 away. Either way. Clear? You see that?
Yeah.
Let's do one more with a negative so that you can see that. All right, let's see. Let's do one more, and then I'm going to give you the homework. So you'll have time to work on it. Y is equal to negative x squared plus sure, why not? 6x, and that is going to be, let me just think for a second, plus 18, so it's going to be 18, minus, 9 minus, sure, why, we'll just do that. 9 minus 2, okay, all right, let's see if I can salvage this graph. I don't have to redraw it. It's so easy. Once you get good at these, you're going to be so much better than everybody else at this kind of stuff, at graphing. It used to take me hours, the way I was taught to do this, hours to graph the homework at night. I mean, like 2-3 hours of homework. Like I could do it now. The homework that took me 2 to 3 hours, knowing this, I could do in 10 minutes. I mean, really, that's how so much easier it is. Okay, so here's my equation. I see it's a sad face parabola. This y, it's standard parabola guy's sad, right? Now, I've got to figure it out though. So I've got to use my axis of symmetry. I see there's a B, so I know the vertex is not on the y-axis. I know it's hitting the y-axis at negative 2 somewhere. The graph is the parabola. But that's not the vertex. The vertex is somewhere else. So here we go. I'm going to say I'm going to use this formula. X equals negative b over 2a. One of the reasons you want to write that is because it's helping you memorize it. It's that important. Okay, 6 is positive. So negative b, negative 6, that would be negative 6, divided by 2 times negative 1, right? Negative 1. A is negative 1. Do you see that?
Yep.
So 2 times negative 1, which is negative 2. Oh, that is negative divided by negative is a positive. 6 divided by 2 is 3, right? So immediately I see my x is 3. And if I want to, right now, I could go over here on my graph at x is 3, and I could put a dashed vertical line at x is 3. Right? Here's my, now I'm going to, what am I going to do? I know my x, I now need to know I find my y. So I plug this 3 back into my original equation, right? So y is equal to negative 3 squared. Now I'm not putting parentheses here because notice the negative is not part of the x. The x is 3. I'm just going to do 3 squared, but it'll stay negative. Does that make sense? Right?
Yeah.
See what I mean? Okay, and then plus 6 times 3 minus 2. What is, I know this is going to be negative because the square does not affect the negative, right? Because that's separate from the x, right? So 3 squared is 9, so it's negative 9 plus 18 minus 2. What's negative 9 plus 18? In other words, what's 18 minus 9?
Oh, it is 9.
Right. So y is equal to 9 minus 2, which is 7, right? So y is equal to 7. So there's my vertex. I've got my vertex. It's 3, 7. So I'm going to now go plot my vertex. Over 3, 1, 2, 3, 4, 5, 6, 7. Right? So over 3, up 7, and there it is. Okay? Now what do? Now that I plotted my vertex? It's standard parabola guy's sad face.
So, down 1 over 1.
So over 1, down 1, dot. Over 2, down 4. 1, 2, 3, 4, right? And then I'm going to just mirror it across, and draw my parabola.
Wait, but it's not touching the...
Well, it would touch at negative 2. If I had kept going,
Oh!
it would touch right there. Does that make sense?
Yeah, I'm...
See what I mean? And so, anyway, so that's it. Fist of 5. Does it make sense? Do you get it?
Mm-hmm. But I was confused with the graphing, but I understand.
Okay, awesome, great. So the whole idea is, when you see a quadratic equation, oh, it's standard parabola guy, sad. This stuff moves it over, right? We're going to use our axis of symmetry to figure out where the vertex is. Find the vertex, then a standard parabola guy, sad face. No, Leo, not a happy face, sad face. Come on.
Sorry.
Jeez. Okay. All right. Okay, that's it.